All right, welcome back to another video. This is going to be a prep for my new job on the 25th video. So that means network automation. So we're going to learn about the Python API for Juniper networks. Juniper networks have always been a favorite among the service provider crowd. If we take a step back and look at the service provider vertical, it would make sense that automating network equipment is on the top of their list of requirements. Before the dawn of cloud scale data centers, service providers were the ones with the most network equipment. A typical enterprise network might only have a few redundant internet connections at the corporate headquarters with a few hub and spoke remote sites connected back to the HQ using the service provider's private multi-protocol label switching MPLS network. But to a service provider, they are the ones who need to build, provision, manage, and troubleshoot the connections and the underlying networks. They make their money by selling the bandwidth along with value-added managed services. It would make sense for the service providers to invest in automation to use the least amount of engineering hours to keep the network humming along. In their use case, network automation is the key to their competitive advantage. In my opinion, the difference between a service provider's network needs compared to a data center is that traditionally service providers aggregate more services onto a single device. A good example would be MPLS, which almost all major service providers provide, but rarely adapt in the enterprise or data center networks. Juniper, as they have been very successful, has identified this need of network programmability and excelled at fulfilling the service provider requirements of automating. Let's take a look at some of Juniper's automation APIs. Juniper and NetComp. NetComp is an IETF standard, which was first published in 2006 as RFC 4741 and later revised in RFC 6241. Juniper Networks contributed heavily to both of the RFC standards. In fact, Juniper was the sole author of RFC 4741. It makes sense that Juniper devices fully support NetComp, and it serves as the underlying layer for most of its automation tools and frameworks. Some of the main characteristics of NetConf include the following. It uses extensible markup language, XML, for data encoding. It uses remote procedure calls, RPC. Therefore, in the case of HTTP or HTTPS as the transport, the URL endpoint is identical when the operation intended is specified in the body of the request. It is conceptually based on layers from top to bottom. The layers include the content, operations, messages, and transport. So here's our layers: content, operations, messages, and secure transport. At the content layer, some examples are configuration data and notification data. Some example operations are edit config, which is part of your configuration data. Some example messages are RPC messages and RPC reply messages. Those are things that would be tied to configuration data. Another example message is notification message, which is part of notification data. And then for under the secure transport layer, both relating to configuration data and notification data, we have things like SSH, TLS, beep/TLS, and then SOAP, HTTP, TLS. The other thing besides SOAP is REST. So I'm surprised REST isn't listed there. So that's the NetConf model. Juniper networks provide an extensive NetConf XML management protocol developer guide in their technical library. Let's take a look at its usage. So this is good to know. Device preparation. In order to start using NetConf, let's create a separate user as well as turning on the required services. Okay, so we're going to need a Juniper lab device. He's using Junos Olive, but as you might know from, if you're a fan of my other series, where we come along with me as I earned the JNCI ESP, which I kind of feel like I made a mistake right now because I think I would have been better off making a video for that right now. But hopefully there's time to do both. But you will know that I am very adept with using Junipers in GNS. So I've got my control plane and my forwarding plane all ready to go. Just got to wire them up. All right, so, and then, okay, good news. Oh, bad news. But I can add another one. Like yeah, I can just add another. What I could even do is just, but I think it's got to be powered down. Oh, I got to delete all the links. I can do that. Oh, come on. I'll give it 2 more in case I need to add something more later. So the adapter does not exist. Adapter 4 does not exist. Let's just use the other Ubuntu server. I think that'll save us some time. We might have to do some steps over again, but that's not always a bad thing, especially when you're trying to learn something new. You just get extra practice, and one of the keys to learning is having that repetition there, so there'll be no problem with that. I do want to try a different VNC client though, so I'm going to stop this and then do a configure on it and change the console type to Spice. I don't know if I need the agent as well, but yep, and then I will start this again. And we'll see if that Spice VNC is better than this one. We'll be able to put them side by side to compare. All right, but we need to go into the Juniper and make some configuration changes. Oops, and I gotta open the control plane in order to do that, not the forwarding plane. So it's going to take a while to come up. Juniper's in GNS. GNS really isn't designed for Junipers, so it's just run as a virtual machine, and it takes a long time for it to boot up. It's not like it runs off of Dynam IPs or that GNS has some sort of special optimization to make them run efficiently like it does for Cisco's. So unfortunately, well, let me see if I can read ahead while this is going. And So, oh, okay, yeah. So it looks like um, it looks like I ran out of batteries on the mic I was using. So for a while I was just a blank sound. I apologize for that again. I really need to figure out, kind of get my act together in regard to this. So yeah, this is just battery powered, so batteries don't last super long. And then when it gives out, there's no warning. I can hook it up to a USB, but this is pretty old, so the USB port is not a cable I have. All right, so now we're gonna do a git clone. Yep, looks like everything went good. And my sound is working again. Again, I apologize for that. https://github.com and see All right. So, yep. So this takes a bit of time, but we'll be all good to go with the and we'll be able to. One thing we can do actually now is run these Juniper commands. Now that the Juniper device is booted up. We'll just call it foo, what they called it in the book. All right, so we got our Juniper default config set up. So let's add the config that's in the book. It doesn't let me resize this. Everything's just a nightmare. Okay, I can do it without looking at it, I think. Oh, seriously? All right, so we couldn't see what we were typing in there, but we will show compare and make sure everything is good. So, we got sort of SSH telnet, and we had to set up netconf as well. I'm kind of curious to see more about netconf. So allow netconf connections. Let's check out what options we've got under here. So we can make the netconf sessions compliant to RFC 4741. I wonder what RFC they are compliant to right now. We can allow it over SSH. We can make them compliant to Yang schemas. And we can tweak settings for Yang modules served on this device. Let's see about tweaking the settings. So we can emit extensions. We can serve Yang modules specific to this device. So lots of stuff we can do. Let's go to this config. Oh, and yep, we're generating our host keys. So hopefully we won't have the problems we had hooking up to the Cisco devices, because this is going to be a more modern device. Oh yeah. Why did I type in port 20? It's going to be port 830 for telnet. Yeah, telnet is port 830. So it looks like I did have a typo. I missed the 3. So it's going to be 830 for, sorry, not for telnet. Did I say that? Review the tape. Well, what I meant to say is that netconf, the port for netconf is 830. All right, so we are good to go. Let's continue on. So, yep, so we did a show configuration pipe display set. Everything looks good. So on the Juniper device, you can always take a look. Yep, we read that. Now let's do a pipe display XML. There we go. There's another really good command where you can do display XML. Oh, and my hole just turned black again. I prefer not having that happen so I can see what I'm typing. So okay. Well, there's a command where you can, let's see here. So figure private, show pipe displays, XML, and then let's edit the whole GP, set group, test, under 10.10.1. So show pipe display XML. I thought there was a command where I can so unfortunately, I thought there was a command where you can see what you would need to send in XML to configure the command. but it looks like on my lab devices here, I don't have that ability. So it's a command that is on a device that I've used in production, but that the lab devices I have unfortunately do not have that extra ability. So let's keep moving on. So yep, everything looks good. So we installed the libraries. Yep, we did that. So now we are ready to look at our first Juniper NetConf example. So, well, it's 8:07, so I'm going to cut it short here. And it looks like I didn't actually make any progress, but we'll be good to go for the next video. Thanks for watching. Well, one final thing I'll do is set up management to this device. So I'm going to do an exit, or I'm going to do a rollback 0, I'm going to exit, and then show configuration, display set. So, yep, I'm going to need a connection to the Ubuntu server. So, yep, it's going to be on GE000. So, configure private, edit into GE000, unit 0, set family INET address, 10.10.10. Let's make this .1/30. Quit. Well, let's see what they're using actually. Okay, so they're using 192.24.252. So let's use that. And 252, so that's, if we were doing a /30, that would be a network address, because we'd have 4 addresses, and 252 would be the network, 253 and 254 would be the host addresses, and 255 would be the broadcast. So we can't use a /30. Let's just use a /29 and get on with our lives. And then let's use the GUI to configure a address here, and then make sure they can ping each other, and then I will cut the video so I can walk around the lake behind my apartment and watch the sunset. So let's see here. This is going to be on now. Why did the other one turn off when this one turned on? I would like them both to be on, as was the case for the other device. So how come when I turn this one on, that one goes off? There's more than one cable. And why does that happen for this device, but it doesn't happen for the other device? Why do similar devices behave differently? Do they have the same MAC address? No. What if I just use a different port? I use the final port. So, okay, so in the, looks like only one port can be connected at a time. I mean, I guess it's not a big deal to just have not have internet access when I'm configuring here, but it's just kind of lame. But it's not a showstopper, that's for sure. Okay, so yeah, let's just have it like that, and then whenever I need this to run, I'll just flip it over, but of course I'll need to remember to do that. So maybe if I get rid of this connect automatically. Okay. All right, well, I guess that's the best I can do. So yeah, so I'll need to remember that. I'm sure it's going to go horribly wrong and trip me up a few times, but we're going to cut the shooting or stop the video right now and come back to it as soon as possible. So thanks for watching, and I'll see you in the next one.